Okay students, again welcome. This is our fourth experiment regarding estimation of acidity of a strong acid by using pH meter. So we need to find acidity, that means in strong acid, that means hydrochloric acid, sulfuric acid, nitric acid, all these are strong acid, and acetic acid and some other acids are weak acids. But in this experiment we are going to estimate. Okay. In this experiment, we are going to estimate hydrochloric acid, which is a strong acid. We are going to estimate the strong acid by using pH meter. Just like acid need to be neutralized with a base. Okay. Here we will take a strong base, which is sodium hydroxide, and here we will take in this experiment hydrochloric acid 0.5 molarity, 0.5 molarity. 0.1 molarity of sodium hydroxide we will take in microburette, and 25 ml of 0.5 molarity hydrochloric acid taken into beaker. Okay. So before that I am going to explain regarding what are these experiments. Just come close and we will show you. This is the pH meter. This is the indicator. Okay. So the pH, that means the pH value will be indicated in this position. This is the temperature. Okay, pH is a temperature dependent, one of the parameter. If you can increase the temperature and decrease the temperature, the pH is also may varies. Okay, this is the calibrator. Okay, we can calibrate by using this knob, and this is the modes, the pH, and in millivolts, in different temperature conductivity we will conduct at a different settings. Okay, we have kept this one in pH mode, so we are going to do the experiment pH mode. Okay, so this is the stirrer. Okay, this is a stirrer. This what it will do now, this is the magnetic bead. Okay, this is the magnetic bead. We will put this magnetic bead into the solution, and if you can switch on, and if you can turn this knob, it will at this certain RPM, rounds per meter. There is a magnetic bead still into the solution, and there is a magnet is present into this stirrer in the downside. So by in olden days, in that we are playing with two different magnets in a plate, that means any plate. If you can keep one magnet on the upside and another magnet on the downside. Okay, so if you can try to move downside magnet, it will also move. Just like the same phenomena is also that we are observed into this magnetic stirrer. Okay, actually in olden days, before invention of the stirrer, we are using one of the glass rod. Okay, we need to make a uniform solution by using one of the glass rod. But we have a facility in our laboratory, this magnetic stirrer. So we need to keep this magnetic bead into the solution. Then if you can switch on, and it will stir. Okay, why we need to use this stirrer means, if you can add NaOH, it needs to make a uniform solution. Okay, so for that case we need to use this stirrer. Okay, this is the pH meter, this is the stirrer. We need to use 250 ml beaker. Okay, for our titration we need to use 250 ml beaker. Okay, so for hydrochloric acid solution, taken 25 ml into this beaker. Okay, so in your procedure, it is indicated 50 ml beaker. In 50 ml beaker, 25 ml need to be taken. But for our comfort, to put this magnetic bead and make a uniform solution, if you can keep this one of the this is a combination electrode. Okay, it may be broken if you can while it is stirring. If it is touch this electrode, it will be broken. So it is very expensive. For that case, we need to use 250 ml beaker. Okay, so and this is the combination electrode. This is the combination electrode. So this is a reference electrode. This is the polymer membrane electrode. Okay, ion selective polymer membrane electrode, which is suitable to find the concentration of H+ ions. Already I have explained you in the first chapter regarding electrodes from the electrodes in the category of ion selective electrodes, first one is a polymer membrane electrode, glass membrane electrode. This is the glass membrane electrode which is ion selective electrode, which is suitably for ion selective for H plus ions. This is the combination electrode. Why I am saying is this is the one of the indicator electrode, this is the reference electrode. Okay, so by the potential difference between indicator electrode and reference electrode, we can find based upon this potential difference, this pH meter will shows by calculating the potential difference, it will indicate the pH value. Okay, this is the combination electrode. Okay, so we are going to estimate pH of hydrochloric acid by using this combination electrode. Okay, so let's do this experiment. Before starting the experiment, we need to calibrate this solution. Okay, so actually neutral water pH is 7. Okay, that means neutral water means the drinking water pH is 7. So we need to calibrate this electrode and this pH meter into 7. So we need to calibrate this one. Now it is calibrated. Now it is a pH 7. So it's not that much of constant. So we need to observe this one, make it to constant until 7. So then we need to do the experiment. Okay. Now it is pH 7. So now it is constant. So we continue our experiment. So in this beaker we need to pour 25 ml hydrochloric acid, which is 0.505 normality, and you need to take, this is the acid solution now, you need to take it in one of the measuring cylinder. I have poured this 25 ml, 0.05 of molarity hydrochloric acid into 250 ml beaker. Then I have cleaned this one, magnetic bead, and putting this magnetic bead into this beaker from the box. Okay. So if you can keep just like that, maybe sometimes the base may be broken. So you need to be careful while putting this magnetic bead into the solution. Then you need to keep this one in a side, and you need to keep it here. So let's switch on this one, and we can capture this one.
आज चेसाना
Now it is rotating. Now you can see the magnetic bead is rotating in acid solution. So you need to make a very slow rotation. Okay, no need to higher rotation. Okay, so 300 and between 300 350 is enough. So make a slow rotation. Okay, so now your solution needs to be clean. Okay, so already it is clean, but still we can just for our reference purpose. Now you can keep this calibrated electrode into the solution. Okay. Now the pH of the solution is, it is showing almost 0.3. 0.3. Why? Because the concentration of the H plus ions is very much higher in this solution. Okay? The concentration of the H plus ion is very much higher in this solution. So in this solution, why? Because this is contains the hydrochloric acid. Directly we have taken from the reagent bottle to here. So we need to take this one, and we have kept the combination electrode into this solution. So the H plus ion concentration is very much higher. So the value of the pH is 0. Now it is comes down to 0.22. Okay, you need to tabulate in your procedure. 0.22 is the pH. Okay, so now we need to add each and every time 0.1 ml. Okay, of NaOH. Already I have filled in this microburette 0.1 molar of NaOH. Okay, so I am going to add. Please be careful. Don't let this NaOH can fall on this electrode. Why? Because maybe sometimes your values may be varied. So now you can add 0.1 ml. Sorry, not 0.1 ml. 1 ml. Okay. So 1 ml. Now already it is stirring, so your pH will be increases. Okay. Now if you can observe, you can see in here 0.3. Why? Because the H plus ion concentration is decreased. So now the value is almost 0.3. So we need to calculate that one, 0.3. Okay. So again, like this, we need to add base again and again. So I am going to add another 1 ml. Again, the concentration of H plus ion is decreased. Now it is showing 0.42. Okay. So now it is showing 0.42. Again, I am adding another 1 ml of NaOH. Again, the concentration is increased, decreased of H plus ion. Now it is showing 0.64. 0.64. Okay. So now I am again adding another 1 ml. Now it is directly jumped from 0.64 to 1.12. 0.64 to 1.12. Okay. So this until from 1.12 we will do another two values. Okay. To draw a graph. Okay. I will show you regarding how the graph will be looks like, and I will take another two values, which is now we have 4 ml. We will take another 5 and 6 ml. We will add another 5 and 6 ml. It is jumped even more further. It's almost 9.5. 9.5 pH. Then we will add another 1 ml, 6 ml. We will see any further change. It is very equivalent. So now it is almost 10.3. So the value will be very similar from 0.64 to 1.12. From 1.12 the value is changed drastically from acidity to basicity. Directly it is jumped from acidity to basicity. Why? Because 1.12 is acidic pH, whereas 9.5 is the basic pH. Okay. So the complete neutralization point is at 9.5. That means from acidity, which is 0.05 molarity of acidity, will be neutralized by NaOH. Why? Because NaOH plus hydrochloric acid, the reaction will be NaCl plus H2O. Okay, sodium chloride and water will be liberated as an products. So in this experiment, so 9.5 is the one of the value which is jumped from acidity to basicity. Okay, so if you can plot a graph between volume of NaOH and pH, we will get a graph like that. Okay, you can see on the board. Okay, we will get a graph like this between volume of NaOH and pH. Why? Because from the volume, from starting point, it is a 0.2. Okay, from it is from slowly, it is very constant. From suddenly from 1.1 to 2, it is rising directly from 9. Okay, the pH is increased. Okay, so it is the one of the calibrated curve for between volume of NaOH and pH. So again we need to make sure what is the exact point which is neutralizes that 0.05 molarity of hydrochloric acid into from by using NaOH. We need to do the another experiment from which point, from 1.12. Okay, 1.12 to we will do again 6 ml. Okay, so again we will come back. Here you can take, already this experiment is over. This experiment is over. For the first procedure, we will take 25 ml of hydrochloric acid and we will take NaOH and we have added each and every time 1 ml. Then we have observed the pH. Okay, so each and every time then again 1.12 immediately 9.5 ml it is increased from 1 ml, 2 ml, 3 ml, 4 ml, 5 ml and 6 ml. At 6 ml the point is increased drastically. So we need to do 3 ml. Okay, that means 5, 6 and 7 ml. Okay, so between these 3 ml, right now we will add each and every time 0.2 ml. That means we are starting from 5 ml now. We will add 5.2 ml, 5.4 ml, 5.6 ml, 5.8 ml and 6 ml. Again 6.2, 6.4, 6.6, 6.8 and 7 ml. Okay, so like this we need to take almost 5 to 7 ml. Then we will see what is its observation. Okay, possible. Okay, this is again the second step to find exact point where the neutralization point. Okay, actually we have confirmed that tentatively 9.5 ml, but we need to make sure that is 9.5 ml or not. For that case, we need to start. Actually, that the transition is observed from between 5 ml to 6 ml. So for that graph purpose, we need to do 5, 6 and 7 ml. Okay. So now we need to observe carefully from 0.2 ml onwards. So this is again I have taken into this beaker 25 ml, a fresh 25 ml. Again I kept this magnetic bead and I have kept this combination electrode and I have observed 0.2 ml. Now at 5 ml we have observed the change. So now I am pouring directly of all the 5 ml into this beaker. I have taken again 0 ml in microgrid. I have taken again NaOH in 0 ml. Okay. Now we need to pour until 5 ml. Okay, into this beaker. This is almost 5 ml. Okay. Now I have stopped. So after 5 ml, it is almost 1.12. Almost 1.12 previously. Now it is become, it is showing a little bit higher value.
Okay.
Okay, ma'am. This is now I have added 5 ml. Then each and every time I have added, and it is almost 1.12. It is a very equivalent to 1.12 value. So almost 1.22 it is came. So now I will add each and every time 0.2 ml. Okay. Now this is a microburette, no? So that you can observe each and 0.2 ml means from 0.2 ml that you can observe very easily in this microburette. Okay. So I have added each and every time. So each and every time when it is increases, why? Because we are adding NaOH. Now the pH is also increases slowly. But when it is comes to 6 ml, it will jumps directly from 1.122. It will jumps directly from 9. So then we need to note down that value from 6 to 7 ml. Again we need to add 0.2 ml for the graph purpose. Okay. So then after completion of the 7 ml, okay, 7 ml, you will we need to do the calculation. Okay. So I will show you in the calculation section. The calculation, it will be like this. The calculation, it will be like this. Okay. So from volume of NaOH and the pH. So from each and every time, here they have 8 ml. Okay. So but we got 5 ml. Okay. 5.2, 5.3, 5.4, 5.6, 5.7, like that we need to take. Okay. Then what is the pH values? Under delta V. Okay. Delta V is the volume of NaOH. Okay. 5.0 plus 5.4. Okay. 5.2. Okay. Divided by 2, then we will get this value, delta V value. Okay. So then delta pH is the first value divided plus second value divided by 2, you will get pH of delta pH value. Okay. So delta pH by delta V, then you will get the value between delta pH divided by delta V. Okay. Then the average of the solution, that means from this delta V value, then you will get like this, and from this average that you need to calculate. And then if you can plot the graph between delta pH by delta V divided by average volume of NaOH, then you will get a graph like this. Okay. So you can see in here, you will get a graph like this. That means average volume of NaOH between delta pH by delta V. This is the delta pH by delta V. Then you will get a graph like this. At this point, at this point exactly, we said tentatively 6 ml, but it will be maybe 6.3 ml. Okay. So 6.3 ml is the required volume of NaOH to complete neutralization of hydrochloric acid. Okay. This point is, we will take it as 6.3 ml is required volume of NaOH required neutralization of hydrochloric acid. Okay. So that is the two graphs that we can, from the calculations that we need to draw. That regarding the calculation part, etc., everything that I will explain to you in experimental session. So then you have understand it, I believe so, you understand it, how to do the experiment regarding to estimation of acidity of strong acid by pH meter. Okay. So I will see you on experimental session, virtual experiment session. So then I will explain to you clearly the theoretical part and also experimental part by video graphically. Okay. Thank you very much.